Hello, everyone. It is Wednesday. It is already 5 o'clock. We're kind of, I don't know, it snuck up on us today. We're just like, oh God, here we are. So, hello, I am Carrie Sundra with Alpenglow Industries. And today, this is our weekly Wednesday solder sesh. And the idea is to just, bring a project, bring a beer, come hang out with us while we work on a project and drink some beer too. And so the project this week that we're working on is a new board of ours. And it is both an homage to Ruth Bader Ginsburg there that you see, as well as being a development board for the smallest, least capable Atmel AVR processor, the AtTiny 4. People have asked me a lot this last week, why? And my answer is because. Just because. I mean, it's an interesting challenge. Like, what can we do with this teeny tiny processor that has like 512 bytes of flash, what can you get it to do? And, I think it could be cool for some like very, very small projects that like you don't have actually the space for an 8-pin part, right? Maybe you only have space for a SOT 23.6 part. And it's also pretty cheap. It is still, I feel like it's increasing by a few cents every week. I think it's up to like 37 cents now. But anyway, it's still pretty cheap. It's actually like, it is legitimately cheaper than even the other AtTinies and like the most popular AVRs, which are more in the dollar plus range. Hello, Bob. How's it going? It's good to see you. So yeah, last week, so this is the second in our series. Last week we did the schematic layout or the schematic design, and we got to the point of associating footprints with our parts and importing everything into Kicad. See last week for Kicad versus Kicad. It doesn't matter to me which. I just say Kicad because that's how I said it in my head for a year or so before I actually heard people say it out loud. But anyway, so we got to the point of importing footprints. And now today we're going to do some layout. But before we do layout, we are going to do the first thing that you should always do with every board, which is double check your footprints. And now you can get to the point where you have a library that is yours and under your control, and you know what's going on with it, and you know that these footprints are good, and that's great. You should still order the parts that you're going to use for the board and make sure that the parts are also what you expect, because there can be differences in width of even common footprints. So there are SOT 23s and there are SOT 23 wides, and same for SO8s. There can be SO8 wides and normal SO8 like narrows. And, there have been a few times where I'm like, oh yeah, I'm using an SO8 part. I know my SO8 pattern is good. And I didn't catch that the part was actually like a wide. And then when you get it, usually the wides are like, you can just shoehorn them in, but it's not great. It kind of barely fits on the board. And then you feel like, oh, very sad. So I really like to get a batch of the parts that I am actually intending upon using, just to make sure that the parts are what I think they are and that the footprints are what I think they are. Also, something that I said last week is that I've been doing circuit board layout for a long time, but I'm new to Kicad. So I'm very familiar with Altium. That's what I've been using in its various incarnations. Although I miss Pcad. Pcad 2000, man, that was such a good program. So anyway, yeah, been doing this a long while, but you might see me stumbling and learning a little bit with Kicad because I'm just not familiar with its tools and the way that it selects things and things like that. But I'm learning, and it's actually been a relatively painless process. A lot easier than I thought it was going to be. I thought I was going to have like gripes everywhere about going from one to the other, but I have been pleasantly surprised. And especially with artwork import. That is so much easier than Altium. Oh my God. Like, oh, and that's just, I don't know. It's embarrassing for Altium. $10,000 and you can't freaking import a picture. Jesus. But anyway, yes, Bob, not only do you have to learn the sizes, you have to learn all the variations of the sizes. I know, right? But fortunately, hey, it's time for a break from our sponsors. Not really, our sponsors are ourselves. So, hey, we make these really great rulers. Don't mind the X's. These are just cosmetic seconds that we use here around the shop. You won't be sent one with an X, I promise. But we have the what the sod ruler and the for the love of sod ruler. And this is why I call them those things, because it is kind of frustrating and it leaves you screaming sometimes when you're trying to navigate through all of the variations of all the different packages. And the thing that's cool about these rulers is that I spent a lot of time doing a lot of research and looking up all of the various package names and alternate package names for more or less the same footprint. So what these are super useful for is identifying alternates, which we are all scrambling on doing right now with all of the supply chain shenanigans that are going on. Crazy electronics part shortage. You design something into your board, you go to order it, it's already out of stock. What do? I've already designed the board's already being made, I need these parts. You look on your trusty ruler and you do a bunch of awesome DigiKey parametric searching according to all of these different kinds of patterns, and hopefully you will identify something that will work. All right, woo! Just throw those anywhere. So enough about our wonderful sponsors, Alpenglow Industries. You can buy it on our Tindy store. We're gonna go to parts checking, and we've got microscope cams set up here. So how do you check parts? It really does help to have a microscope or some sort of magnification at this point. This is where that's kind of needed. You can also use one of those ring lights. You know, those are pretty good. You can use the little eyeball thingamajiggers, the things that go around your head. That Sigourney Weaver wore in Ghostbusters. You know those things. Or whatever magnification you have is good. I have a microscope. I love using a microscope for everything because it's so comfortable and awesome. So we're going to use the microscope here and show you. And so you import all of your parts into the PCB layout. You print it out 1-to-1. That's important too. Make sure that the scaling is correct. And then you just like literally place your parts on top of the printout and see what it looks like. So that's what we're going to do. You're going to see what it looks like. All right, let's switch over to microscope view. Wow. So this is our printout. You will notice that the writing is backwards. That's because everything is on our bottom layer. So so that's why the writing is backwards. Oh, everything's on our bottom layer. You know what?
Is it backwards?
Yeah, I mean, I don't think for this layout it might not make a difference, but it might.
Pretty symmetrical.
So yeah, I think we have like mostly symmetrical stuff, but we're just gonna do this the right way because it's always good to do this the right way. So right now I'm just selecting everything right now. That's not the full layout. It's just sort of more or less like semi parts placed. I'll go over that in a minute. And then I will click them all so that I have them all and click F for flip. And that puts them, oh, that's interesting. It also rotated them. That's kind of odd. That's a difference I'm not quite used to, but whatever. It's okay. Like you could easily just R and rotate them again. There we go. So we're going to print this out again. And then we'll check them against the printout so that they're the proper way. But yeah, it probably would have made a difference for the SOT 23 parts for the 3-pin ones. We will print it out. Sure, we'll try color and see how that goes. Sometimes printing them out in black and white is better. It kind of depends upon your printer. You might notice with magnification that your color printer uses like more dots, or especially if you're trying to like make gray colors or something like that. So a lot of times printing in black and white just gives you like better precision. But the blue at least came out pretty well for us. So we were just going to go with the blue. Yes, paper checkout of parts for PCB layouts. Totally. I'm a huge fan of checking stuff out on paper. And like even doing like paper dolls with your PCB to see if it'll fit in places sometimes. It's, you know, it's cheap, it's easy. There's no excuse for not doing it. All right, let's see. We'll go there. Okay, hey. All right. Yeah. So here are our things. Let me see if I can focus that just like maybe a little bit better. I don't know. And like there. That's about as good as it's going to get. So here we are. So because I'm new to Kicad, I haven't checked any of these patterns yet. So we're just like going to go through a whole bunch of them right now. First one we'll start out with is, let's see. Let me get I just want to point with a pen. There we go. First one we'll check out is this one. This is just a header that is, if you want to, optional, if you want to solder it on and stick it to a breadboard. So basically this is just going to go right like that. And so this will come as part of the kit, just as a separate thing, not soldered on yet. And the black, you know, retainer part will be off of the board. So these pads will be like pretty much right on the board edge. The black will be off of the board. And I wanted to give you a little bit of extra room there to do the soldering. So looking at this through the microscope, that looks pretty good. There's like a nice amount of space around each of those pins to have like a nice flowed solder joint. And there's like a little bit of room at the end of the pad to like get a soldering iron tip on there and heat up the whole thing. So I'm pretty reasonably happy with that. Yay, check. So the next one, oh, I can already see we're going to have a problem here. Need to redo a footprint. Interesting. So either the data sheet was wrong or I had maybe an interpretation of millimeters to inches that was wrong. I was doing this last night at home and didn't actually have the parts with me. So you're getting live parts checking here. So yeah, obviously this is not going to work. The pads of the pattern are too close together. It does look like, however, the body size, it's not the right length, but the thickness, the width or the tallness in this view is about right. So that's good. So yeah, we'll have to work on the pitch there, and we'll have to work on the length of the body itself too, but it's pretty good. It's also worth noting, like, okay, I feel like these pads could also be closer together. So, so basically that top row and the bottom row could be a little bit closer. They're just like right on the edge of the flat part of the leg. And I always like leaving a little bit of pad behind that flat part of the leg so that you have a nice solder fillet in back as well, so that that leg will just be captured on all four sides essentially by solder. So, and, you know, there's a fair bit of, you know, it's just like they're a little too far apart too. They're a little too wide. So basically what I would do is I would take that pattern and move the pads, move that top and bottom row a little closer together, and then space them out differently according to like what the actual pitch of the part is. So, all right, so we have to do some work on this guy, and I'm gonna like circle this guy so that I remember. Excellent. JP1, that's just a solder blob jumper, so there's no parts checking for that. This one, oh, actually I need this part too. Could you grab, they're the surface mount 6-pin headers. They're like with the badge stuff, like in that section, there's like a white bin that has just a bunch of them loose in it. They're for the like F Unicorn programming. Yeah. Yeah. Okay. Cool. So that's this one. This is a normal like ISP AVR header basically for programming, but it's just the surface mount version. So the one thing that I don't have this one. So we'll have to wait until later to double check this dip switch pattern. But now we can go and we can check these are 0603s and those are SOT23 and these were default patterns that came with Kicad. The SOT23 was also marked as a hand soldering pattern, so that's why the leads are a little bit bigger and it's like a little bit wider. I thought, why not use it? Yeah, perfect. Thank you so much. But before that, we can go and check this surface mount guy right there. So you'll notice that I've marked pin 1 with the dot, and I've also marked this pin 3 is outlined, and that's because there's a keying notch in the header. And so a lot of times that's just visually easier to identify and to double check that like the notch is in the right spot. And so, yeah, I'm not super thrilled about this pattern either. I definitely want to adjust that. You'll notice that the pads on this one are actually like a little bit, the 2 rows are like a little bit too close together, right? So we want to take them and move them apart. So we want like these guys to go that way and these guys to go that way. So we'll circle that one as well. Yeah, not by too much, but just by a little. And by the way, like this kind of thing is totally normal. Like you build a footprint for the first time, you check it, you tweak it. It's definitely an iterative process. So yeah, and like I don't think I need to alter the size of these pads at all. I just need to like move them that way a little bit. All right, so put that one over there by the switch. Okay, so 603s and SOT23s. We have some examples of each. So this is SOT23 part, just a generic resistor, and that'll be fine for checking. Ooh, and now, yes, I would love some tweezers, please. I thought I had some in the bin right there, but apparently not. We'll get out the SOT23 package right now as well. This one is for the N-channel MOSFETs. Oh, thank you. And awesome. So let me do that. And look at this. This was also the hand soldering pattern. Oh yeah, that's nice. So it has like a nice bit of pad on either side of that resistor. So, that makes it totally hand solderable. It doesn't have too much pad inside here. That's good because sometimes you need to actually like run a trace through there at times. That helps you do that. So yeah, that's a really nice pattern, and it's not like too tall, which is good. Cool. Yay. Now we will check our SOT23. You're upside down, little dude. There you go. Okay. These are all sometimes a little weird. Oh, those are really long pads. So this pattern is fine. And like this board isn't super space constrained, so it's not a huge deal. And we are intending upon, having this board pre-soldered. This is not going to be a soldering kit. So there should be no reason for a user to actually need to do anything with those parts. We could keep them as is, or we could change the pattern to be the slightly smaller one. Doesn't really matter. Either one would be fine. For automated assembly, it might actually be better to use the smaller one because that will ensure that all the solder stays very close to the pin and will actually flow to the pin. With these, it is like possible that you could get some pooling in places that are not by the pin, but probably not. I mean, it would probably be fine with most automated processes. So there we go. So that one's all right. Maybe we'll put a question mark by it and say like, go to smaller, maybe? Okay. And now we have the switch up there. This is also a Kicad provided pattern. And so for Oh, we don't have the, oh, I didn't print out the holes. Or the holes didn't print out. That's interesting. We'll see. Usually I do try to print out outlines for the holes. There are 2 pegs on the underside of this guy, and that's used for locating the switch, making sure it stays in place during the reflow process. And so yeah, even though this is surface mount, it is a little bit through hole, which is fine. It was fine. That's why we located it on the edge of our prototype board so that it wouldn't interfere with the artwork. And it does make these nice to use into solder. So I'll usually verify that those holes are in the right place too. And I'll do that by like putting this paper on a little bit of a squishy material and just like, once I've got everything lined up, just like pressing it in, and then I'll check the indentations in the paper and make sure that they are where the holes are and they all line up. But this pattern is looking pretty good. It's a little bit wiggly right here because it's not laying flat because of those pegs. But I am reasonably satisfied with this pattern. I mean, if it were me, like I would actually make those pads a little bit bigger. I think that they're a little bit small. I would extend them probably all the way around just by a smidge. But I would say that this is sort of like a minimum acceptable for high density boards. But definitely that pattern is not very hand solder friendly. Let's see, where are we going? Okay, ooh, SOT236, that's going to be our processor. This one's an important one to make sure it fits. I'm already feeling that looks a little like skinny. It looks a little thin. Looks a little narrow, but we'll see. Might not be. Okay. That is our tiny little processor. And yeah, it's not bad. It's not bad. However, I think I might see if they have a different footprint for this or extend the pads. So this one I actually would like to make more hand solderable because if somebody, so the board is going to ship with an @tiny4, but maybe somebody wants to try using like an @tiny9 or 10 because they have more space, a full K instead of only 512 bytes. I want to make it easy to basically just like solder blob and wipe this component off the board and, swap it out for a different processor. So, and that's going to be, the soldering it back in is going to be kind of tricky to do because there's not much space around those pads. So again, this is sort of like a minimal pattern for more high density layout. So yeah, I might put this back carefully in the bag. So I might put like a note on this guy to do bigger pattern for hand soldering. Cool. All right. And now we have these crazy weird LEDs. What is going on here? These are right angle surface mount LEDs. So you can actually see that little dome is the LED lens. And we're going to grab one of these guys and put it down and see what we can see. Yeah, and just let me know if you guys have any questions or anything as we're going along here. Totally happy to chat whatever aspect of this strikes your interest. There's like a lot of detail-oriented work, I would say, in circuit board layout. Like there are a lot of steps, and like I know a lot of people like to rush to quote unquote the fun part, which is like actually laying down the traces. But it's like, you can spend a lot of time in layout just to realize that you missed a detail or made a mistake at one of these other parts, and that kind of ruins your day. Totally ruins your day. So this is a pretty nice pattern. I like this pattern, fully carry approved. So it has, it has like a nice bit of space around all of the pads. these are nice and long so that you can have a nice big solder fillet going up to them, those two. And these two on the ends that are used for both signal and mounting are good. And it has a nice outline of how far this lens sticks out. Because in this case, like if you don't have outlines in your silk that represent your actual part, you can accidentally place things too close together, and then you get your board and you notice that, oh crap, these two parts kind of are overlapping. Like their bodies are overlapping, even if their footprints don't. That's made a little bit better these days by having 3D models and having 3D clearance checking, but I don't know if Kicad actually has 3D clearance checking. And it's just always good to catch that at the parts placement time before you've routed your board, because then it's way easier to change things before you have all those traces down. So yeah, that's an awesome footprint. Thank you. Made my life easier on that one. Yeah. Let's see. So I think the last, don't shoot your part across the room. I think the last one is this battery holder. And had an interesting conversation with David of Cyber City Circuits this morning about these. I was talking to him about some problems that I had with a different manufacturer, and basically what happened is there was, I know which one this is made for. Interesting. It's made for a slightly different version that probably has like the holes in the middle. It has a bigger ear with a hole in the middle. Actually, could you look in that battery holder bin that we have? I think we have some that are surface mount they have like big ears on the side with a hole in the middle.
A hole in the middle.
Yeah. So anyway, we use these on our pre-assembled I-voted boards. And what happened was like this material, it is tin plated, it is solderable, but solder really doesn't like sticking to it, especially the lead-free stuff. And so, the solder bond between this leg and the pad just wasn't that great. And the whole way that the battery is held in is just with spring tension from these two fingers. And so, and we were also using the battery holder to like as the mounting surface. So we were putting magnets on it and like putting pins on it and stuff, sticking pins to it, stuff like that. And so like the first few that we sent out, there was actually a problem with the whole battery part just like popping off, just like coming right off, like the pads just were not well soldered. And, it's just, I don't think it's necessarily the board house's fault. I've also had that happen actually with a few, boards that are just battery holders with a switch from Adafruit. I've had that happen. So I think it's just, David was saying that this is a big metal piece and it's a big heat sink. And so I think it basically just kind of sucks up all the heat and prevents the pads from getting to quite the right temperature and from the solder from like flowing as nicely as it should. I also suspect that the lead-free solder just doesn't wet out to this very well to begin with too. So basically, even though I was talking about it, I was like, well, I'm intending on having him assemble this board. I'm like, what do you do? What do you do for these? And he's like, we just hand solder them. And like, that was essentially what we had to do on the I-voted boards, was we had to go back through and just like drown these ears in solder, just make sure they were fully ensconced. And then it wasn't a problem. Then they were fine. But it's a pain in the ass. It's like, dang it. That's why I'm doing surface mount stuff. That's why I have like 10,000 of these on a reel, like, so that it can all be automated. And now we're having to go through and hand solder them. So it's a little bit of a bummer, but I think it's just going to be the way it is. So yeah, I think that this pattern is really for this style of battery holder with the ears there. And I'm also kind of curious, maybe if this might stick better. I don't know. I'll have to look at the cost though too. All right, Bob has some questions. I'm going to go to Normal view. Hey, back again. Okay. When I modify parts library, 2 versions. Yes. So what I generally do is especially when I'm working with like libraries that are pre-installed, like a lot of the Kicad ones are. What I'll do is I'll make a copy of that component and I'll put it in my own library. And then I will generally like rename it, and it'll have some modified name that goes more along with like my parts naming scheme and indicates what the modification is. So yeah, I do that. I do that a fair bit. So, oh, nice. There's a space launch today. Cool. Very cool. Love it. Yeah. So, yeah, that's mostly it. That was the last part that we needed to check. I think right now the only one that I'm going to change, all the other ones were like relatively close. So, even if I start placing the parts and laying out the board, I can alter those later and it won't have that much of an effect. However, the switch one definitely needs to be changed. It needs to fit more. So I'm going to go ahead and modify that footprint now, and we'll reload it and reprint it and see how that looks, and then talk about this layout and talk about the graphics. Cool. So I think I'll make this guy big now. Awesome. And okay, so we're going to go to this guy. Now, I haven't figured out yet. Hello, what's going on? Oh, yeah, close. Thank you. I haven't figured out yet quite how updating between the library and the layout works. There does seem to be sort of a way of going back and forth, but maybe not all the time. So let's see. I'm going to just do that. And do we have an option here? Ooh, open in footprint editor. Perfect. Nice. Cool. Load in, load in. What? Drinking beer while it's loading. Any day now. It's like that last little bit, like the last like 0.1%. That always takes like the longest. Okay. There are no details to see. What could we do? I can talk a little bit about maybe I can't zoom back out while it's doing this. I could talk a little bit about errors were encountered. It does not exist. It does so exist. What's going on? Weird. Okay. Weird. Seems. Might have to relink my library here. Let's just do that. Add library. Kicad. Libraries. Well, can I do 2 of them at once? No. I'll do that one. And that will be a global library because it's our general Alpenglow library that we're doing all of these, keeping all of these modified footprints in. Cool. There we go. And then I'm also going to, hey, where'd you just go? That's weird. Okay. So, okay. Footprint editor. Oh, weird. Just went to my, wait, no. I'm so confused. Too many screens. What's going on? Okay. So that is fine. Where did it go? Footprint editor. Oh, there it is. It's just like behind 10 million things and doesn't want to maximize. Oh, okay. Weird. Cancel. Haha. Success. All right. So we're going to modify that switch. I wonder if the other library that our, okay, yeah, the other library that our artwork is in is still linked. So that's good. So yes, I think what I will do is kind of ignore the data sheet, which the data sheet was a, for this part, it was a Chinese part that I found for this switch. It's a 4-position dual throw switch. So that means it's switching 4 signals at once between 2 positions. So it's like a little bit specialty, not unheard of, but not super common. And so it's a Chinese part that the data sheet was sent to me as a JPEG. And so it was hard to read the little tiny numbers. They were all kind of blurred together. So not super surprising that we have like a footprint that's kind of off. So basically what I'm going to do is I'm just going to measure it with some calipers to see what we see here. So I'm going to measure the pitch, and I'm also going to assume that it is likely some even multiple of millimeters. So that looks like a 2 millimeter pitch pretty much. So that means that the center of each of these legs is about 2 millimeters apart. So the easiest way, I think, to fix something like this is to go to our grid and just put ourselves on a 1 millimeter grid. And that way we can easily move all of these to be 2 millimeters apart. So, so yeah, it's going to be, and we wanted to move them closer together a little bit anyway. So if they move down a little bit on the grid, that will be okay. So we'll see how this goes. So we'll select that and move it to over there. And we'll select number 5, move it over there. Select 4, move you there. Whoop, nope, not there. Where are you not on the grid? There we go. Okay. And then we'll do the same thing with 1 and 2 and 3. So now, because our grid is set to 1 millimeter, we know that like if all of these are two grid dots apart, they're all 2 millimeters apart. Yay. And now we remember that this body width here was about right. And so I think that those pads are actually in a pretty good spot. I think that they're now moved in enough that more of the pad, there will be more overlap between the leg and the pad. So just going to do this on these guys. And I mean, you know, I could like kind of start over and regenerate everything on a grid, but I don't think that was the fastest way to make changes here. We're also going to grab the circle. It's going to be a little hard because it's not on grid, and keep that by our pin 1 right there. And then I am also going to measure how big, let's see, how wide this guy is. And that is 15 millimeters wide. So we'll see if we can just like pull this guy to be on grid. I don't know if I can select him with it being so far off. No, not quite. Well, I could just do that, maybe. That. There we go. And now let's see. I can pull, but it doesn't. If I do G for grab, will it work? No. Maybe? No. Okay, that's fine. We'll just extend everything later. So 15 millimeters, so that's going to be like, our center point is in the middle, so it's going to be like 7.5 millimeters that way and 7.5 millimeters that way. So it is going to be like a little bit off. So I'm going to set our grid to 0.5 millimeter. And so now we know, like, one of the, I don't know, something that I do a lot, at least when I'm doing like little fixes like this, is that I'll add another line briefly, because when I start a line, it will tell me in the corner right there how long the line is. And so I'll just make a line. I know I want it to be 7.5 millimeters long from the center point there. Center point is probably a little bit hard for you guys to see. There is actually a blue square. Like there are some blue crosshairs in the middle here that are dark blue that are showing up for me. So that's identifying the center point of the part. So anyway, so now I am 7.5 millimeters from the center of that part. So now I know that I need to move this over to there. Oh, that one's going to be, this one might be a little bit hard to do. Well, we'll see how that goes in a second. We'll move the other end over first, maybe. There's several different ways that you could do this. You know, one would be to like get half of it right and then like copy and paste to the other half, and that's like totally legitimate. So I'm just going to move that guy over to here. Yep. Select. Again, I am not the best at selecting in Kicad yet. And then, so now maybe what we'll do is, maybe we'll delete this. And then, haha, just start a new line there, put it all the way over to there. Perfect. And then we'll do the same thing. And I'm going to delete the other one first because it'll be easier to see and select right now. Come on. Oh, still in the drawing tool. There we go. Select, delete. And then put this there. Cool. And then, yep, select that and get rid of our extra line. All right, so I think now this switch pattern should be pretty good. We will save it. And just want to make sure that it is, in fact. Oh, shit. Where the hell did we just save that? What happened? Okay, so apparently it did not associate itself with its footprint, and it was using some cached footprint. Huh. I did press Control S for save before I switched, but I have no idea where it just saved it. So yeah, there's definitely some interesting Kicad-ness that I need to figure out at some point in time. I don't think it's, oh, that's weird too, that there's nothing in there. It didn't do anything else there. Interesting. Okay. Well, what happens if... Aha. Okay. So it did seem to actually update it on the board. So that's good. But we have some sort of like linking issue with the component in our library. So that will be something that I can figure out later. However, for right now, what we can do is we can print this out again. So, and just check our pattern to see if it is good. Excellent. Bob says he's drinking root beer, and any kind of bubbly beverage is totally good with us. Oop, I don't want to plot. You know, bubbles just make things more fun. I mean, so does alcohol, but if, you know, that's not your thing, that's fine. All right, so here we go. Going to print again. Cool. I'm like, what was that ding? Watch, right now it's finally, our printer's finally going to decide that it's out of toner, right? Oh. Cool. That is, yeah, that's interesting that it is, I think because that library wasn't linked at first, it didn't quite link the components to it. So I'll figure that out later. But cool. Thank you much, Robin. Now we shall see if I am any good at measuring. Hey, that's looking much nicer. We'll make that bigger for a second. Yeah. So now our switch fits really nicely. I like the way that those pads look. They have like a little bit of space around them. Lots of room for solder. That's awesome. And the overall length is about what the length is. So yeah, I think we're good. We don't have any components sticking out where there's no silk. So that, I believe, is a good representation. Sweet. Cool. I'm just going to save this. Just going to save. Awesome. So go back. We'll go back to here briefly. So, all right. Now, our footprints are pretty much checked. The other ones are just pretty minor tweaks that I can do later. So now we're kind of back off to the races in terms of placement. Now I'm going to flip this back around to the other side, rotate it. There we go. So I generally laid out these parts where more or less I knew I wanted them to be. Oh, maybe I should go into the graphics first. So graphics, even with the nice importer that Kicad has, it's a little hard. It's a process for sure. And so, you know, I grabbed like the portrait image of her off of the internet and then did a bunch of modifications to it so that it would be kind of like the right format for printing using the silk screen. And what I had to do, let's see. Oh, hello, there we go. Let's see if I can share kind of the progression with you here. Oh, box. There we go. Because there were several steps, and I did actually write about it on the Alpenglow blog. It is like specific to how you do everything for Altium, but a lot of the image manipulation kind of is basically the same before you actually import it. So Altium is a little weird in that the easiest way to get an image into it is to like actually grab it from Word. Like copy and paste on the Microsoft clipboard for whatever reason is like the easiest way that Altium handles images. There are other ways too, like importing DXFs, and there's some awful converter that they have that never worked very well. But basically, you know, I had this image, I made it a negative. I had to do, because in this case, so what you see in black here is actually what you will see printed in the silk. So because like normally for a black and white image, right, the black part is what's printed. But for a circuit board with a black background, it's the white part that's printed. So therefore we had to do things in negative. The black is now representing our white silk screen. So it's a little mind bendy to think about until you kind of get it all set. So so I did a lot of like back and forth between negative and not negative in order to get separate outlines for like her ears and like her cheek here and stuff like that. And I did a lot of just, hand drawing, clicking in Inkscape in order to kind of, just pixel editing in order to do that. And so, these are a few various stages, various sizes. I needed to simplify her crown a little bit too. So, so yeah, you can see here is sort of like a more normal image of her. And then I had to actually outline her. Otherwise, her hair is going to be black. If I didn't outline her head in white, then, it would just blend into the entire background. So yeah, so there are a few things that I kind of had to do there. And then this is the negative image. And so I actually kind of created two images here because the thing is I didn't want her crown in silk. I wanted her crown to be actually on the solder mask layer. I wanted that area to be free of solder mask so that she has this nice gold crown, which is pretty much, let's see if I can put it over here and show it to you. Pretty much what we have going on there. Can I do that? No. Okay. So, right. So now I actually have two separate images pretty much. I had to separate the crown out as a different thing. And for me, it was just easiest to draw her crown as a very complicated polygon with the normal polygon tool on the solder mask layer. So what I did here then is, I'll go back. Let's see. No, we'll just keep it. We'll keep it there. So what I did here was I just removed her crown. So for the final image, but the initial thing that I imported was her with the crown. So that's why over here, you'll see that I actually have two images on the screen. So this is her with the crown. Originally, I used that over here within my board outline there. And I kind of drew this four crazy complicated polygons. You can see there on the solder mask layer. That's one, that's one, that's one. This is another one. And so I just drew that over the silk screen. And then I, moved this one and added this one and just, lined it up with her crown. And then I'm using just pads actually as the little crown tips so that I didn't have to do some crazy outlining of those. So you can see they have pad numbers in them. And I'm going to figure that out a little bit later. I'm sure that there's going to be some DRC issues, or if I'm going back and forth between the schematic and this, that, it will probably bitch at me a little bit and try to delete those because they're pads that are on the layout and not in the schematic. And if it's trying to sync the two up, it tries to get rid of stuff. But so I'll keep an eye on that. Or I might find a way to place them in the schematic as as a bunch of no connect pads. And that might help that situation. But in order to actually do the importing of the graphics, Kicad is super nice because it has this tool that is the convert image tool. Oh my gosh. And so it opens this window. Let's see if I can, I can't make the text bigger for you there. But basically you load a picture. So we'll load a bitmap just to kind of show you the process here. These were the original files. So yeah, we can see, maybe do that one. Yeah, so we can do that one. So no, we'll do that one. Okay, so we'll open this guy. And so now you can see the picture that's been loaded. This was I had already converted it to pretty much pure black and white. So there's really not much to see in the grayscale. Black-white threshold, that will just, if you were converting from a grayscale image, that would adjust the amount that gets, converted over to black. But since this setting doesn't really matter right now, since we had already started with a fully black and white image, and then the PCB new format saves it as a component. So it saves it as a component in a component library. The one kind of bummer is that you do have to be aware that the picture that you upload is already the right size, because you can't sadly resize it once it's been imported into Kicad. And that's kind of a bummer. It would be really nice if you could resize it once it was in there. But it is, I'm not going to complain about that because the rest of the process is pretty good. The other interesting thing that you can see is that, I wish I could make this a little bit bigger, but this is actually quite pixelated looking because it's been converted to a fully black and white image and doesn't have any kind of dithering effect on it. Usually the edges of images, even black and white ones, are a little bit blurred to make them look smooth. And I don't know what magic they do with their converter, but you convert this image and it became actually a lot smoother and a lot crisper, which I was pretty impressed with. I thought that was pretty nice. So anyway, that's how I went about drawing that. I've read that there is a plugin for Inkscape, I forget what it's called, something to Shenzhen. And it's basically a plugin for Kicad that lets you manipulate images in Inkscape and export it to a particular layer. So that would have been super handy in this case, because maybe if I was better at image manipulation in Inkscape, then I could have made that crown in Inkscape as a separate thing and then exported it to the solder mask layer in Kicad. So that's something that I'm going to experiment with in the future when I don't already have most of the manipulation done. The image originally, it's a bitmap. So yeah, the built-in Kicad one, I don't think it allows you to load PNGs. It says load bitmap. So I am assuming that is the only file format right here that says load bitmap. So I think that might be, but
for my clouds, the original ones were
PNGs. Did we resave it as a bitmap before importing it, or did you just import the PNGs?
I'm pretty sure I just imported them.
So yeah, Robin thinks that she just imported PNGs here, probably, using the same tool. And I feel like I have that memory too, that it wasn't exclusively bitmaps. So it might be a little bit of legacy naming, and it might actually load different files. Actually, we could let's try it out. What do we have? We have that image there. Do we have anything else? Let's try an Alpenglow logo. So, okay. So we'll do that. We'll do I don't know. We'll do primary logo maybe. Do just the black.png. Yeah, let's try that. Yeah, does seem to load. Mm-hmm. Grayscale picture, black and white picture. Yeah. Let's export it. Let's export it to our Kicad folder. Libraries. We'll just use it. I might make the Alpenglow load a little bit. We have one logo in there already that's the horizontal, so I'll call it Alpenglow logo. Save. Okay. So now we could place a footprint on the board. And up and low. That one. Okay, there we go. So, I mean, that's pretty freaking easy. definitely compared to Altium, that's pretty easy. And like, if we're zooming in, it's looking pretty nice. Like, you know, the sharpness of the letters and everything is pretty good. I feel like the mountain has lost a little bit actually in translation. The point of the mountain is not, like, in the peaks of the mountain are not quite as sharp as I would like them. So because it's our logo, I would probably screw around with that a little bit. I know it's probably not noticeable to anybody except me, but you know. And I feel like the text is a little bit fatter too. It might be something where it like takes, you know, it converts and kind of makes these shapes based upon like outside external boundaries, maybe. So anyway, but it's not bad. You know, you can see that's our actual mountain down here. So you can see that like as the image format, like it's a little sharper in here, and that this lettering is a little bit narrower. But yeah, for a PCB, it's silkscreen. It's probably gonna be a little gloppy anyway. So yeah, there we go. So yes, in the Bob asks if the earrings are also copper pads. Yes, they are in this one. I have not. Those weren't actually copper pads. I think it was just a copper fill with openings in the solder mask. So they're just polygons that are drawn in the solder mask, meaning that there's no solder mask in those places, because you always, on solder mask layers are always a negative. So what you see are areas that do not have solder mask. So yes, and that is something that I will eventually add to her here as well. And, you know, all you have to do basically is zoom in and change to your mask layer and grab the polygon tool, and like, you know, we can start drawing something like that. I'm just going to do something quick here. It's not going to be the final one, but you can do that. And there you have a place that's free of solder mask. And all I would have to do is like do a ground fill on this layer and make sure that there are no traces going through there. And then that'll show up as a solid copper spot. Yeah. But I'll just like delete that because it's not very good. I'd be more careful about it. But yeah, I decided, so like in her Supreme Court photo, like she's wearing some sort of earrings. I don't exactly know what they are, but you know, I decided that they needed to be a little bling on the board. Just need a little bit. Yeah, awesome. So where are we going now? We are going back to the layout. I'm just going to also, let's see, delete this. Just, I don't know if that takes up a lot of processing power or not. So I basically like placed parts more or less where they were going to go, because I wanted you to see them and kind of see the kinds of things that I like. I basically almost start routing the board in my head when I'm doing the parts placement, because everybody has their own styles. So this is not right. This is not wrong. This is just how I do things. I am used to making boards that are very, very space constrained. And so I don't necessarily spend much thought or time or effort on lining up components and making the components look all neat and tidy. I think about lining up the copper and lining up how the traces are going from one side to another, because I want to like minimize vias. I want to minimize the amount of time that things are crossing, because every time you add a via, that takes up more space. And anytime, you know, you add a trace on another layer, that takes up more space. We only have 2 layers to work with here. We're not doing a multi-layer board, so our options are limited. And also, like, the cleaner your traces are, that means like the more unbroken your power planes can be, which is just kind of nice in terms of like noise and low impedance. So so yeah, I'm basically placing parts and immediately thinking about how all of the signals are connecting to each other. Oh, hello, Liz. How's it going? Thank you so much for joining. And thanks. Here, I'll zoom out a little bit in case you missed the full thing. But yeah, doing a Ruth Bader Ginsburg board here. It's the RBG RGB board because there are going to be RGB LEDs behind her eyes. And the idea is that I wanted to see what I could do with an attiny4 processor. And I wanted to see if I could do like rainbow fading with it, like having 3 PWMs, even though it only really has 2 outputs and stuff like that. So yeah, this is it's all working on the breadboard. And I do have one version that was an early prototype that I learned stuff with that didn't really work. So yeah, I'm now, and the original version was also laid out in Altium because that's what I was most familiar with. And I wanted to redo it in Kicad and make it open source and more friendly and accessible. And also have it able to be used as by somebody else as like a dev board for playing around with the attiny4 processor. So yeah, that's the quick rundown on what is it and why does it exist. So yeah, okay. So we'll zoom in a little bit more here, and I'll just go back to the schematic to refresh it a little bit because I mean I've got pretty much the schematic in my head right now, but I'm sure you all don't. I've been looking at it a lot. So I did change the schematic symbol for these LEDs, so it's something that I like better now. So yay! So these are the 2 RGB LEDs. They're being controlled. They're being switched on and off by N-channel MOSFETs. And then we have like a bunch of extra weird stuff going on so that it can also be used as the dev board. So this half of the board is sort of the RBG half of the board and the RBG functionality, which you can isolate actually from the processor and with a programming header and stuff like that, so that you can actually just like isolate that part and then put your own circuit on a breadboard and basically have the processor pins go out to a breadboard here with the 10th inch header, and also have the programming connector on the back of it as well, which is also going to be like a solder it yourself, like little extra one. And then there's this other switch here because the attiny4, because it has so few pins, you have to multiplex the programming pins with like normal IO pins. And so depending upon like what you have on the rest of your circuitry, it may or may not program if it has stuff hanging off of those pins that pull current. Even like LEDs and FETs, sometimes it just doesn't really work very reliably. So what this switch allows you to do is isolate all of your signals and have them go just to the programming connector. And then you can slide the switch back. It's a 4-pole dual throw switch. So it switches all 4 of those lines at once. And then you can switch it back, and then it'll be like in normal runtime mode, and it'll either go out to your breadboard here, or if these are connected, it'll go out to the LEDs and stuff and do the rainbow fading. The other thing that it will do, there's like one extra little switch that allows us to switch between rainbow fading mode and red pulsing angry from the grave mode, which she is right now. And so that allows us to do that. And then this is just a basic on-off switch. It either connects the battery to V processor that then goes to the processor, or it just, keeps the battery floating. So that is the board in the nutshell. And cool. Thank you, Bob, for the recap as well. And so those are what all the components are. So now we'll go back to the layout where we see them all. So this is the dip switch that isolates the RGB, the LED part from the rest of the board. This is the switch that is programming mode or not programming mode. This one right here is our programming connector. And this is for soldering a header to then be able to like plug it vertically into a breadboard. This is our @tiny4 processor. And these are our 3 N-channel FETs that switch on and off the RGB on the LEDs. These 2 are our RGB LEDs. They are going to be side mounted on this board, and everything is on the back of the board. There's going to be openings in the solder mask on both the back and the front of the board. So using the FR4 itself, the fiberglass, as a diffuser for these LEDs. So they will shine through the board. And then these, still getting used to Kicad. And then these 2 switches, this one here is the mode switch, the pulsing red versus rainbow. And then this one here is on off. And then that's our CR2032 battery holder. So those are all the components. And so now, so now basically like the layout is determined by a few things, right? So we're going to have to put the LEDs behind her eyes. And so, you know, I've just placed them over here for right now, roughly in the middle there with roughly the right spacing. The battery wants to go at the top so that we can insert the battery into it and shove it out. Switches can kind of, you know, they kind of don't matter too much. That was just a convenient spot for them. Then we have on the bottom, the other thing that's kind of fixed is the breakout connector. So we definitely want that to be on the bottom so that you can just like plug her into a breadboard if you want to. And like pretty much that stuff just sort of then determine the rest of the placement of the parts. So, you know, because this guy is down here, you know, we want our dip switches that connect our RGB circuitry nearby. We want our programming or not programming mode pretty nearby because it has a lot of the same signals going to it. And then, of course, that should be near our programming connector over here. And then, you know, our microprocessor is just kind of at the top in the middle of all that. Decoupling cap is close to it. Pull up for the reset pin just to keep that nice and stable. This is just an LED that's off of the power for the programming connector so that you can just get a visual indication if you have plugged in a programmer, if it's powering your board. All right. So it's really easy to spend a lot of time here and to just keep tweaking and keep tweaking and keep tweaking, especially if this kind of stuff makes your brain happy. I don't know, like for whatever reason, I just like get really into layout and to connecting the dots and making it flow as nicely as possible and like doing really efficient layouts and stuff like that. You know, you don't necessarily have to spend a ton of time here. You can definitely spend too much time and just spend a lot of time rearranging things and not really getting anywhere. So it is all a balance, right? But you know, I got to this point and last night and, you know, I was kind of looking at it, letting things grok, you know, grokking it. And I also always listen to music when I'm laying out circuit boards. It just like helps with the flow of things. Like it, I don't know, keeps me from being bored, I think. And it just kind of like gets me into the groove. And what I'm listening to totally changes. So it just depends upon whatever I'm in the mood for. Yeah. So when I was looking at this, I was like, okay, this is not too bad. We have like the processor over here. We have PB0 out, which is up there. So maybe that could route down here. Maybe the processor could go right here. And then we have like PB1 out right here. which goes over to here. And then, oh, that's going to have to cross PB3 going here. And I was kind of like, I don't know. Maybe I want to rearrange some of the way that some of these signals go into this switch to make it a bit nicer to route. And then I was also like kind of looking at this over here. Like my first inclination is to sort of like, oh, you put the components so that the text is upright. Well, like it doesn't really matter. You can rotate the text and you can rotate your components. So I was looking at this one and we have this going to red over here, this going to green up here, which I could pull out that way and go here. And this one going to blue, which I could pull out and then like actually goes up to the switch. And I'm like, oh, and then, all the other outputs are on this side and they're kind of going over here. That kind of makes sense. But then I was like, oh, you know what? I could just like grab this and I could rotate it. And then like that red, green, and blue, the red, green, and blue routing gets like a lot nicer because green is now just going straight up here to this resistor and that transistor. Red is going up over to there. Blue is a little bit weird because it goes up to the switch and then comes back down. But even so, that's, a little bit cleaner. And then, oh, look at this. So I have PB0 out going over to here, PB1 out. I might be able to take around here and get over. I'm probably going to have to do some vias in here because there's stuff going up and down and there's stuff going right and left, right? So, definitely going to have to use both layers for sure. But I'm like, ooh, I feel like that looks a little bit cleaner to me. And then I was thinking like, oh, this is interesting. I have stuff down here. I kind of have this one that's rotated now. Like what happens? Maybe what happens if we rotate this one too? Will that actually help us out? And I'm like, it might, maybe. Like, yeah, that way definitely doesn't look as good. So you can kind of get a feel for how much your signals are crossing, how much of a rat's nest it is by looking at your rat's nest. So all of these white lines that are bungeeing around right now are actually going directly from the pad to wherever else they're connected, wherever else that net is connected to. So you can kind of see sometimes, like right now, I feel like there are a lot of crosses and stuff. If I do that, there are fewer. They're kind of like going to either side. And so I'm a little bit intrigued by this. I'm not entirely sure that this is the right thing to do, that this is better than, than our original one there. But I don't know. I feel like it does look a little bit better. So I might try putting this like up here maybe. And then this one, this is like this jumper is in case you have one of the old Atmel programmers that does not power your board, that actually needs power instead of providing power. This is so that you can just solder blob across and do that. I think that like most people, this will not be a thing that most people ever need to worry about or think about. So maybe we'll put this guy like there. I'm going to squish all these in a little bit too, maybe, because I know that this is like a little bit wider than my board. So that's actually another reason to put that switch vertically, because it is pretty wide and I might not actually have enough room for it unless I rotate it. This jumper is going to need to be accessible somewhere, but again, we'll find out a good place for this in a bit, I think. I think we might want to move that in, but of course we don't want it to overlap our header down there. So I might try moving this in that way a little bit. And then I will move our LED and resistor out of the way there, out of the pattern opening. And then our solder jumper here. JP1 is what we want to grab and put it over here. Okay, that's starting to look like something maybe. So what I'm going to do is I'm now going to put this all inside. I think though, before I do that, I'm going to place her eyeballs first, because like those are arguably like the most important thing, right? So I will move this over. Well, that looks pretty good. And then move this one over to here. Zoom in here. Let's see, make sure she's, you know, really looking straight at you there. That feels pretty good to me. I know, she looks so creepy.
Were you planning on changing the eyeballs at all?
Yes. Yeah. So in our prototype board, learned a lot of things. One is that if you just do a round opening in the middle, oh my God, she looks like crazy zombie Ruth. It's a really creepy effect because it's just like a hole where the eyes are that's glowing, right? Not a good look. So what we're going to do this time is, instead of creating just like a round circle hole in the solder mask, we're actually going to do a ring. And I'm probably going to try to actually just to do an incomplete arc, so that there's like, basically you get like most of an iris and like a little hint of like a glint sort of, you know, in her eye. So yeah, so that it looks like her iris is changing color instead of like zombie pupils. So yeah, we'll do that. We'll do that later. But really, I just wanted to place those diodes because I kind of want to, you know, hide this layer now, because I just don't want it to be visually distracting to me when I'm doing the rest of the laying out of all of the parts. So I think that those are pretty good. I want to see, there should be a way, I think, to like lock the positioning of these so that I don't accidentally move them maybe. Lock footprint, there we go. Excellent. And so we will do the same thing with the other LED. One thing that I do that is like a little bit of a bummer is that you can't select like several things and change properties of all of them simultaneously. I'm used to having that kind of editing capability available, so I'm having to kind of like relearn. And it seems like Kicad has a few things that are a little bit helpful, but yeah, it's a little different. Oh, that's funny. I just saw your comment, Bob, about rotating the dip 3 switch. Yes, in fact, it would. Yeah. So yeah, so okay, so now those two are locked, so I can't accidentally move those. I don't think I should be able to move the silk screen once I'm not seeing it, hopefully. We'll see if that was a correct assumption or not. I'm going to save right now because I like saving things. So, oh, and I want to, interesting, maybe I will turn the top off too so that I don't accidentally move those pads. So, okay, now what I'm going to do is I'm going to start moving these things over, and we're gonna move the battery holder over first because that's definitely going to be a large thing. Oh, you might be asking yourself too, like what's up with the board outline here. I originally drew it with like 1/8 inch radius corners, and then I realized that our original board was actually like, or 1/4 inch radius corners. Yeah, our original board is actually 1/2 inch radius corners, really big radii on that corner. And I like the way it looks a little bit better with the larger radius corners. I would really love it to be like this super cool oval board with sort of like ornate border, like a brooch kind of style. But doing an oval board like that is going to like it's going to kind of increase the cost quite a bit because the area is going to be bigger. So it would like both increase the cost and make it more difficult routing wise. So, and also like you kind of need some space for this battery and stuff, like, yeah. So it just, things were not going to fit on it as well. So still having the big radius of corners, like kind of, evokes the brooch. I'm hoping. Yes. Save early, save often. Yeah, totally. Like I grew up on an island that had frequent power outages and I cannot tell you how much shit I lost. Learned that one early, but still, you get used to things being reliable and then the power goes out. Okay. So got those going on there. Switches, I'm not going to worry about these yet because they're not super important. Then this guy is important. It needs to be on the bottom and like kind of in the middle here. So we'll do that. And then I think we will do these three. Hey, whole thing. Thank you. And see how I've done on that. Oh, look at that. Not bad. I might, yeah. I lost a, I think that's just an artifact. That's weird because the pad seems to, yeah, it's just a weird artifact. Huh. I know that was kind of weird. Like the pad was still showing up over there. Huh. Yeah, I think, yeah, that's pretty good. I could still move this like up and out a little bit. Same here if I needed to. And I am, so this pattern actually is going to get a little bigger. The pads are going to, get spaced apart a tiny bit more. So this is probably a good spot for that component. Yeah, I might now, I might see like sometimes like there's, a little bit of OCD-ness in board layout. And it's like, oh, it'd be really nice if the switch was right in the middle. Right. But I'm not sure that that's actually, not sure that that's actually going to work out very well because like this component is, I think, wider than this one. So I don't know, like that is more in the middle. Yeah, that might work out. Yeah, we'll see how that goes. And then this one, I think we'll give ourselves like a little more space over here maybe and put this like right about there. So that'll just give us some space for signal routing or whatever over here. That might be nice. All right. Like what else do we have going on? All right, let's drag the rest of the stuff over here. So we'll put our transistors over here. Those are probably all pretty good. Like, oh, those are gonna, okay, that's easy though. I can definitely scooch those resistors in a little bit. I wanted to kind of keep a little bit of room here. The writing doesn't matter too much right now. I'm just kind of ignoring all the writing. We'll figure out what is going to go on the silk screen at the very end. In fact, like, I don't know if anybody knows if there's a way to hide all like reference designators. That would be interesting. I don't want to hide the entire bottom silk screen layer because I still want to see my part outlines for placement, but I just want to hide the all of the reference designators. I don't know. I mean, so I can, hide this one. Can I now I don't think I can duplicate properties on this like I can on pads. I can't push those properties to all components. I don't know. That's something that I'll have to look up. And also it's interesting. So it's it's hiding it, but it's not hiding it, right? So it's not really on the silk screen layer anymore, but it's on some other layer that is not hidden. So I don't know, is it I'm looking at these layers over here that are in gray. I'm trying to see if I turn any of them off. Oh, that's nice. That just courtyard information. Yeah, that just kind of dejunked it. I don't really use courtyards. I use silkscreen to show part outlines. I think it's better. Bottom fab. That's what layer it was on. So yeah, so that, that helps us a little bit. That declutters things. But I do still wish I could just like hide all reference designators all at once instead of just clicking through them. But that's okay. Oh, and then I think our resistor, yes, our resistor was like kind of close to this LED here. So I'm just going to scooch these together a little bit. This can kind of go down there. This doesn't have to be that close. It can be over here. Like similarly, if we want to be all like symmetrical and nice, we could put this one over there. That looks about right. Cool. And then, yeah, just so we don't forget that selecting so different. Just so we don't forget it. So this is a thing that is probably worth mentioning. Okay, so we have this nice side mount switch here, right? Why am I putting it so far back from the edge so that the actuator is not actually on the edge? Arguably, it would be more user-friendly if the actuator stuck out from the edge a little bit so that you could more easily flick it on and off if you're wearing it, right? But there can be some issues with putting things close to the edge, because if the board is scored along this edge instead of routed, which it might be, because when we think about having this board made, it's going to be made in a panel. So there are going to be multiple boards all held together in a panel. And then that way it just makes assembly easier, because then you have holes and locator marks on the frame of the panel. And that helps the pick and place machine line up on those kinds of things. And it helps you align your board properly. And then, you can populate several different boards at once. Like this might be in a panel of 6, let's say, and so that's all well and good, but then you have to have a way of breaking them out of the panel. And a lot of times this is done with drilling a bunch of little holes and which are called mouse bites, and making it so that you can just like flex the board and break off these tabs. But that leaves kind of a rough edge, which I ideally would like this entire edge to be super smooth, because then it's a little bit better as a wearable. So probably maybe the easiest way of doing that is to, you kind of have to route these round parts, right? There's no other way of, you can't score a round part of the board, because then how do you break that out? You can't. Scores always need to be like horizontal or vertical. So this round part is probably going to be routed. So there will be like a 1/10 inch of space between this board and the next board. And then this vertical part is going to be scored. So there will be a 1/10 inch of space here between this board and the next board. So maybe we could actually overlap this switch. If the following board was going to be like right next to it, right on the other side of that score mark, then you have to be really careful about overlapping components, because it might run into something on the next board. And also it makes it, if you have overlapping stuff, it makes it a little bit more difficult to actually break out if that's a score line. So yeah, that's an interesting thing that I might think about a little bit more later. But I think just kind of to err on the side of caution, I will, for right now, just keep my actuator inside the edge of the board. I can always move it out later. That's generally easier than like moving something in and creating less space for it. So I'm going to do the same thing here with the on-off switch on that side. All right. And then let's see, what else do we have going on? Oh, we have a resistor that we need to keep over with that switch. And then we have our processor and stuff. Cool. So yeah, processor, that looks pretty good for that. And then we have our power LED and our jumper. I'm gonna move you over here for right now. And then power LED there. And I don't know where I want to put this guy. That's 5 volts, that's V processor. V processor is kind of over here. So maybe what I want to do is take this one, rotate it like that, put you over here, take you. Ooh, I'm gonna have to change that diode pattern, that diode footprint. I don't like the silkscreen marking on that. That was just the stock 603 diode in Kicad. What I don't like about, I think that they were trying to make it really obvious as to which pad was pad 1, like which one to line up with the dot or the line on the LED on the which should be the cathode. Sometimes it's not, should be the cathode. But like I feel like by almost encapsulating the second pad, they actually made it not as clear. So I would actually, make a copy of this footprint and change it, and just have a line that's a little bit further away from the pad. That just denotes like which pad is the cathode. Yeah, I don't know. I don't like it. No, sir, I don't like it. And then I'm just going to move this up. I know that like this component is kind of big and tall, and so I'm just going to move it a little bit far away from it. That way, if I need to replace it for any reason, or, get a probe in there or something like that, it'll be a little bit easier. And then we will move this one. I always want to press spacebar. Spacebar is rotate on Altium, so I'm like constantly trying to rotate with the spacebar in Kicad. In Kicad, it is R, which is quite intuitive, but my brain is completely Altium programmed right now. So, okay. So we're looking at this now. I think I'm relatively happy with how this is turning out. Because I always optimize for routing, I'm going to move that over a little bit so that this is centered more or less between the other two components, even though that means it's not centered on the board anymore. And I'm sorry if that bothers any of you. It just gives me a little bit of space between this bank of pads and these pads in order to like put vias in there, route stuff down, over, whatever. What else do I see? I'm looking at the switch now and I'm thinking, okay, so this is kind of nice. So PB2 is going up to the processor. PB1 out is going up here. PB0 out is going right here. Like that's really nice, clean routing right now. Boy, this is actually really nice. Like PB out could go there and right there without having to cross anything. And PB1 out could go here and then come down here. Yeah, V processor is a little. I could, let's see. I could potentially change. Does that make any sense to do that? I could potentially change where like these three pads are all, one signal line that's being switched back and forth. And these three pads are a second signal line that's being switched back and forth. So here you can see that VCC is being switched between the 5 volts that's coming in from the programmer, or V processor, which is actually like coming in from the battery. And so, because that's another thing for the @tiny4 that's like an interesting thing, is that it can only be programmed at 5 volts. So even if you're running your whole circuit and running the processor off of 3 volts normally, like we would be with the CR2032 battery, you have to give it 5 volts to program. So that's like one reason to kind of like isolate the power that is on the board versus the power that's coming into the board for programming, because we don't want to accidentally short our CR2032 battery to 5 volts. That would be bad. So yeah, right now I'm just thinking like this side is routing very nicely. Does it buy me anything to switch 1, 2, 3 with 4, 5, 6, right? Does it make sense to like to switch those? Do I think that I gain any routing stuff there? I'm not sure that I do. I mean, I guess V processor would be closer to here for the jumper. And I don't like the idea of squishing a solder jumper in between these two parts. I think that's going to be hard to get an iron in there without like accidentally burning your switch or burning your connector. You know, I kind of like this being up here that's more in the clear. And I might even like move this LED and resistor off to the side of it too, because I don't think it matters. I don't think I need those to be super close. So that just gives that a little bit of extra space again. So yeah, that might be a little nicer to have vProcessor up there, but I need vProcessor down here anyway. So, meh, I think it's pretty good. I don't think I'm going to mess with it anymore. Oh, did I write a blog on the different AVR programming pin layouts and voltages? I haven't yet. I do want to write that blog article. Thank you for reminding me about that. Yeah, I do want to write a blog article about how to program at Tiny's, which programmers work, what configuration they have to be in, because it's different for the two different programmers, and yeah, and how you can do that through the Arduino IDE or AVR Dude-S using AVR Dude. AVR Dude-S is just a GUI for AVR Dude, which I like using because, hey, I like GUIs versus command line. I know, I'm not a true hacker. Oh well, take away my badge. I don't care. Yeah. All right. So, shoot, should we like start routing some traces? Yeah. Yeah. All right, let's do it. What do you do first, right? That's cool. Where do I even start? You can do it a few different ways. You know, sometimes if I'm feeling overwhelmed, I'll just pick off the easy stuff. So I could like route these traces in here with these transistors and stuff. But I typically start with power first, because power is usually what you, I start with whatever you don't want broken up, right? Whatever you want to make direct connections everywhere is kind of what you want to put down first, because then all the other signals and vias and stuff have to go around them. So it's nice to not break up power, because that keeps your power like nice and low impedance. You might have like different power lines or planes in going through a board. Some boards you might have like 3 volts and 5 volts and 12 volts all being routed around. So, you know, making sure that those are all nicely laid out and unbroken first can be a really good thing. And then in some boards, you know, power might not be your priority. It might be like USB signals, or it might be like an analog video signal, or it might be an RF signal or something like that. So, you know, it depends upon what you're designing and what you're doing as in terms of what to prioritize. But you generally want to put like the things that require the most care down first. So I think we will start with power here. I mean, you know, we're not doing a whole bunch of like high current stuff. I usually do save ground until the end, by the way, because you can usually pour ground on a layer and get a lot of ground connections without actually laying down traces and like junking up your design. So when I'm talking about power, I'm talking about like your positive power, different positive power rails. So yeah, might do that first. So we have, oh, this is a little bit of an interesting thing. V processor there, V battery there. So on this switch, I actually will switch it around, because like it doesn't matter here what the other what the other side of the switch is, because it's just like, is power connected or is it just not connected? So right now we would have to put VBAT down here and then vProcessor out. And it doesn't really make much sense. We might as well just swap it in the schematic because we can, and it'll make it nicer. So here we go, right here. So instead of, we could do it a few different ways, but like instead of V battery going to pin 3, we'll put it on pin 1 and we'll make pin 3 the no connect. So first we'll move. Maybe we'll move the whole darn thing. We'll move the no connect. How do I? Oh, maybe if I, there we go. M for move, and then the no connect. Okay. So, and then we'll go here. Oh, I'm still getting the hang of selecting. Okay, sure, why not? And then G for grab, maybe. Ah, there we go. Okay. So, and then we'll move. Yeah, still really bad at selecting. I gotta like actually read some stuff to figure out how this works. Okay, so now we've changed those two and we'll save. Now, this might be a little interesting. We definitely want to read, let's see. Hopefully this will give us some choices. Okay, so this is cool. So under options, we have update footprints. We don't really need to update any footprints right now. Delete extra footprints. No, we don't want to delete extra footprints because we have extra pads and we have artwork that's a footprint on the board. So leave that unchecked. And same thing for deleting single pad nets. We just don't want to do anything. And we want to keep our footprint and symbol associations. So let's see, update PCB, see what happens. Hey, so now vBattery is coming to that top one. Yay, vProcessor is coming out of there. And then that's our no connect. So that's just, that's a lot nicer. I definitely believe in making your life easy when you can. And yay, our RBG components are still there, which is good. And I just want to make sure our pads, yep, on the top are still there. Awesome. So that all worked like I thought it would, which is always nice. So yeah, let's then go down here and yeah, let's see. Cool. Okay. So might want to zoom out a little bit now so we have more ground. So right now I haven't done a ton in Kicad. I really need to set up my space mouse for Kicad so that I can like move the view with my left hand and keep, my mouse clicking for selecting and stuff like that. Highly recommend a space mouse if you do a lot of work in CAD like this, because it is super handy for being able to manipulate the view, but still have your mouse hand free for selecting and clicking and routing or whatever. It's also really great for 3D image manipulation because it's just more, once you get used to it and set it up right for you, you can just rotate things a lot more precisely and easily. And it's just great to say, space mouse, space mouse. All right. So we're going to route, we're going to do single track, and we'll start at vBattery and we will go to vBat. Now, I don't know if there's a way, let's see, to adjust my track properties on the fly. Ooh, maybe. So in Altium, you press tab and it comes up with the properties for the trace that you're routing, and you can change the width right there. That's what I'm used to doing. What I want to do is I would love to make our battery lines just a little bit heavier. For this layout, it doesn't matter so much. There's not a ton of high current. There's not anything high current going around anywhere, but it is a way of visually separating out your power from your other traces, which I find can be handy. And it's just, you know, kind of the habit I'm into. So, yeah. So, okay, select via track width, maybe use custom values. Ooh, look at that. So we're at 8 mils. So I'm going to make this 20 mils. Hey, awesome. Nice big fat power trace. Love it. Oop, there we go. Hey, awesome. Our first trace routed. Look at that. All right. And so now I'm going to take vProcessor. So this is super nice. I'm glad Kicad has this feature of dimming everything and highlighting where you're going. It just makes it a lot nicer, you know, a lot easier to keep track of like what it is you're doing. So that is our, you know, that's our jumper. I'm gonna do. I don't know. I have a hunch. I have a hunch that we might want to keep our signals. Ooh, interesting. I'm just trying to see if I can get it to route. I don't want it to be quite so close to these traces. There's just not like a reason for it. Ah, there we go. So I had to kind of unwind it by moving the cursor above the bend so that I could then kind of redo where that bend is. I do a lot of that stuff sort of like on the fly, and I like to make my entries into pads nice too. So there we go. So now vProcessor is routed. I'm kind of keeping this side clear to put signals out this way. We'll see if that was a good decision or not in a bit. Does Space Mouse replace or add to the normal mouse? It adds to the normal mouse, which is what is so great. It's not just like a trackball, right? A trackball is just a ball that you can rotate, but it replaces a normal mouse. You're doing all of your normal mouse movements and selection with it. A Space Mouse, I set it up for, like, I'm right-hand dominant, so I use my normal mouse with my right hand. I use Space Mouse with my left hand, and so I have it set to the left of my keyboard, so I can like mouse with this hand and be routing traces and selecting things over here, and then I can be moving the view with my left hand over here, so I can just like pan or zoom in or zoom out or move it up and down, whatever. If it's 3D, I can rotate pretty much in any direction. All the while, I could have like an active trace that I'm routing with my mouse hand. So yeah, that's why Space Mouse is so cool, because it adds the ability for you to basically have like two mice, and one of them is just really set up for moving views. And you can also, you have the choice of setting it up. There are kind of two different ways that people just a little bit intuitively, but also it just depends upon what software you've been trained on and what purposes you've been modeling. People who are doing stuff like visual effects and animations for like movies and games and things like that, they're creating worlds. They tend to think of things from a camera perspective. Like, what is the camera doing? The camera is like zooming and swooping and going around stuff. And so they'll tend to move a view, like they'll think of moving a view as like moving a camera around something. Me, I was trained with solid modeling of creating objects. You know, I just have an object here and I want to move the object. I don't want to move a camera around the object. I want to move the object itself. It's like the Space Mouse is the object that I'm manipulating. And so that's the way that I set up my Space Mouse. And it took a couple days and a lot of cursing before I got it right. But once I got it right, I found that it was like super easy and super helpful. And but yeah, it's nice that you have the ability to kind of set it up however you want. Yeah, it adds 2 to 3 more degrees of freedom to your design work. Exactly. It's super useful. Like anybody who does a bunch of CAD work, definitely recommend it. I am not sponsored by Space Mouse, but I should be. Let's see. Okay, cool. So we have vProcessor there, and then we have, you know, our last vProcessor line is just kind of going down here. So I'm just going to make a nice little break. I might regret this later. You know, we can always change things. Oh, interesting. It grabbed it as small. Huh. Whoop. That's interesting. I'm gonna like Control Z out of that. I wonder why that happened. What happens if I grab the trace? Oh, get back into routing mode, right? Route. Ah, that's interesting that it went back to the skinny 8 mils. Well, whatever. We will use custom values. Now, I could set up a net class for power and be like, hey, all power should route at a default at 20 mils. Like, that would also be a way of doing that. Maybe not 20 inches. I'm also used to things being in mils, not inches, so it's kind of weird. Okay, cool. So now I'm doing this. I'm kind of like coming over here and going into here. Yep. Oh, I'm also used to different things ending ending tracks end. Cool. And let's see. Cool. So that's one thing routed. We could just like route this one. Oh, interesting. So now it is going back. So, oh, actually, hang on. Select check view width. Let's use. Okay, so we're back to small. I just said use net class values. I figured they were defaulted. Okay, I'm getting there. All right. So, and then we could put this one. I guess we could just do that. Yeah. This one up here. And then we could route PB2. Ooh, PB2 is going down there. Ooh. Yep. Okay. Is it going up here too, though, I think? It has to be going to the processor. Yes. So maybe, interesting. Ah, we'll be sneaky. Put it around that resistor. And up there, maybe. Oop. And like I do my best. I take stabs at things, and then, there's a fair bit of rerouting that also happens. So we'll see if there might be places where we'll start putting vias in and switching layers and things like that. But, you just like pick somewhere to get you going. Maybe we'll do our 5 volts here now too. And I'm going to go back to our custom values. Awesome. I'm used to double clicking, like finishing out everything that is on the screen. So that's why I'm having to click more than I'm used to. Okay. So yeah, that's routed over. I mean, we're definitely going to have to, break things up to start getting stuff around. So, we might do a via here with 5 volts to the other layer and put it, down here and just put it straight in. So that will save this layer of like maybe reset can go more straight across, and, maybe TP clock can go straight across. So we might end up, it might make more sense to route power on the front side of the board and leave the back side of the board for a lot of the signals. Right. But yeah. So I know we're also almost at about 7 o'clock, which is our cutoff time, even if we're still having a good time and doing stuff. Because I mean, honestly, right, this is a many-hour task of starting to go through and doing this, but I wanted to at least get started. And I feel like parts placement is so important, and it's something that, especially like when you're just beginning to do stuff, people tend to kind of rush through or not really think about all that much, or they tend to think about it more from a, oh, things need to be lined up visually kind of perspective, where you don't have to do things that way. You can line stuff up so that your signals are a little bit nicer. I know that all these are pretty much going to go straight up and over. The other thing that can be helpful at this point too, and we'll see if we can figure this out right now. It can be helpful to hide certain nets from your rat's nest view. So especially ground, because ground goes everywhere. It will make a giant mess of everything, right? Like it's every component pretty much. And so, I find that just hiding ground gets rid of a lot of the visual clutter and makes me more easily able to identify, where my tracks still actually need to go. Oh, good, Liz, I'm glad. So she says a lot of great tips, especially since she's currently troubleshooting a non-functioning board. Oh no. No, is it a board that you made, or is it a board that somebody else made? Oh, Bob has yet to design his first board. Designing boards are fun. It's totally fun. It's kind of addictive, just warning you. So yeah, I want to see, view if I can. It's a board you made. Oh, I know. It's always such a bummer when like you make a board and it doesn't work. It's like, oh, but I don't know. I guess my main troubleshooting tips for boards that I make that don't work, if you can assemble things, so if you can if it's something that you can hand solder and you have the components and you can do that, and you have extra bare boards and stuff like that, bringing things up in sections can be really helpful. And I just start with power. So like, first populate the power parts and make sure that, the power looks good with nothing connected to it. And then start populating sections and certain components. Sometimes that's not super possible because you have a lot of things that rely on other things in order to work. But to the extent that it is possible, just like really trying to do things in sections work. Hello, Pete. How's it going? You're coming in at the very, very tail end. We're kind of just wrapping up, but that's okay. Like we got all of our parts placed on the board. We started laying down some tracks, just barely, and yeah, it's going pretty well. Everything fits on the board, which is always good, and it should be able to route it no problem. Oh, here, let me get the silk. Oh, that's adhesive. That's and let me hide the bottom. Oh, yeah, have to hide more than just the bottom in order to get the good view here. Like maybe the silk and maybe the mask too. There we go. And the paste. And the paste. It would be nice. Is there like oh, hey, look at that. All copper layers, all but active. It would be nice if there was a easy way, like hide everything associated with bottom, hide everything associated with top. Those are handy things to have. But anyway, that's basically the board we're working on. Ruth. So we'll re-enable everything, and yeah, and we'll disable the silk again to not be distracted. Where's the solder mask? Good. There. I'm very used to the nomenclature being top and bottom, not front and bottom, which is like very weird and disconcerting to me. It's like, okay, front and back, sure. Top and bottom, sure. But like front and bottom is just like conflating two different things. And I'm just like, what are you guys thinking? So, Pete, this does have RGB LEDs. In fact, it is the RGB board. say that 10 times fast after drinking a beer. These are the two RBG LEDs, and they're her eyes. And I'm using the board as a diffuser. So the LEDs are on the back, and the there's like solder mask cutouts for her irises, which will be the LEDs. So yeah. But yeah, right now I'm trying to figure out if there is a way to just hide the ground net from the rat's nest, because that would be incredibly helpful. So yeah, I was going to view, because that would seem to be the show rat's nest and hide any granularity to that rat's nest. Oh, it doesn't necessarily look like it. Can I like select that nest? Can I select ground as a net and hide the net? These are all things that I would generally be able to do in Altium. So I'm just seeing if there's like an analog in Kicad. Footprint stuff. Yeah, exactly. Red, green, blue, Ruth Bader Ginsburg. Yes. RBG, RGB. Because Ruth is first and the LED colors are second. I can see properties, but this is, yeah, so this is giving me properties for the footprint, not just like the ground net itself. List nets. Can I change visibility of a net? No. Nah, no properties. Brr. All right. Well, that'll be something I'll look up online, and I'll see if there's a way to do that. Yeah, but all in all, like honestly, like Kicad is, for being free, it's like pretty darn capable, and I'm pretty impressed with it so far. So, oh yes, and then the other thing that I'm going to do, so you might notice that Ruth below me, Ruth version 1 below me, her face is a little rough looking. And that was because the via holes were just like a little bit too big, and so I'm going to make the via holes smaller so that hopefully like the copper and the mask will just like go completely smoothly over them. And I'm also going to try to not have vias in the middle of her face, but like this is a small board, so I can only do so much. You know, it's quite a bit of surface area, like kind of right in the middle. But actually, I feel like most of the vias are going to be down here, so that might be possible. I might be able to keep vias out of this region. Yeah, we'll see. Yes, the battery crown. Awesome. So yeah, so okay, next steps for the board. Oh, you're welcome, Liz. I hope that helped a little bit. Yeah, that can definitely be super frustrating. I'm sorry. But you get through it. You'll figure it out. I believe in you. Totally. Yeah, so next steps would basically be, I think I've convinced myself to put the power on, to like prioritize power for the front side. So I'll probably keep this the same, but after it goes into this jumper, or maybe like right before here, I'll put that on the front then, and I'll route these power traces on the front. And that way it can help for you to prioritize directions for layers on a circuit board. So what I would do here is I kind of cheat. I prioritize sometimes directions and sections on circuit boards like this, where you only have 2 layers, right? If you have like a 6-layer board or something, you can be like, oh, this layer, all the traces are going horizontal. Oh, this layer, all the traces are going vertical. And that is a great way of doing it, because you basically know you can get out of most any situation, right? If like you need a trace to go from here over to here, then you know that on your horizontal layer, you can just put it horizontally and it won't conflict with any other trace. And then you can put it through to your vertical layer and it can like go vertically and it won't conflict with any other trace. Real life doesn't work out that cleanly a lot of times. And especially when you only have 2 layers, you're going to have to do a little bit of this and that. But I know in general on this layer, I'm going to need to get like signals across to this connector. And yeah, it's kind of like across and down to that connector. So again, it's like a little mushy, right? But I feel like for this section on the bottom layer, I'm going to prioritize horizontal traces. And then like, especially like these power traces, then I'll put on the top layer and they'll be going vertically. However, over here, there's really nothing else going on over here. So it's like, I can just go vertically on the bottom layer over there, and that shouldn't affect anything else. That I shouldn't get into a position where I need to get a trace out of something and I'm like boxed in on all layers, right? That's what that prioritization kind of avoids. Yeah. And then also on both probably layers, I have to think about this a little bit. But yeah, probably on both layers, after I'm entirely done routing it, I will just create a giant big copper pour on both layers and pour ground over all of it. It helps with ground connections, and it can also help with noise to have some ground between different signals. You'll get like less crosstalk and stuff like that. Not that I think that that's going to be a huge issue on this board, but it's just, again, general good practices, right? So yeah, that's probably what I would do next, is make these guys that are going down here be on the top layer and start routing across here on the bottom layer, and then see how far I get there. Yeah. And of course, I will do that little bit of footprint tweaking too that that I talked about earlier. Just making some of the footprints like a little more solder friendly, just like a little more pad area around them and stuff like that. Yes, yeah, dual ground planes. Yeah, I just like I fill unused space with ground. Why not? There's like not a big reason not to, and especially with this board, on the front of it, our ground plane is going to be like her crown and her earrings as well. So we want to have copper on that top layer that shows through, so that we have so that our areas that are free of solder mask are like nice shiny metal and gold. Yeah, so my goal for this, I think I'm probably going to work pretty hard on this for the rest of the week and through the weekend. And my goal is to order these from Osh Park by the end of the weekend, because we're definitely just going to order like a few of these to hand solder and double check. Oh, I probably also will order from Osh Stencils the stencil for this, and we'll do some reflow in. Man, that would be kind of a cool live stream. I'll have to think about that, about how to video that and set up the video for that. We could have like, we could potentially do the stenciling in here, or put the camera out there maybe.
Well, if we use the new camera that has Wi-Fi, maybe we could just have it set up out there.
Maybe. I don't know if it transmits live video via Wi-Fi. We'll have to figure that out. Huh. Yeah, or we could use phone camera maybe out there. But anyway, that could be a cool upcoming live stream, is to assemble some boards. And yeah, that would be good. I got to get new paste. All my paste is old and crappy. Yeah, new paste. Cool. So no, Osh Stencil is not related to Osh Park, although I think that they are friendly. The Osh just means open source hardware. So generic Oshness at the beginning of the thing. And I mean, I think that they kind of, did that on purpose. I think that Osh Park existed first, and like Osh Stencil was like, oh, hey, you provide the circuit boards, we'll provide the stencils. And yeah, they are also a great service. They are super fast. They laser cut the stencils. I always get the metal ones because they are much, much better and cleaner for surface mount. I don't even know they used to do vinyl stencils or metal stencils. I just don't even think the vinyl ones are worth it. And the metal ones are relatively cheap. They're maybe like, for this board, maybe, I don't know, maybe $20 for a set. And they generally are here before the boards are here. So, and you can also, they do partner a little bit. I think that there's an option after you've ordered boards from Osh Park, like, hey, do you want stencils for this board? Go to Osh Stencils. So yeah, they're also like another US company that started small and has been getting bigger and bigger, and they've been able to grow and like get better lasers and stuff. So that's been fun to watch. And they do with frames or without frames. The framing is a little bit expensive, and since we're only going to be assembling a few boards, we might go frameless, even though we haven't used our frame aligner all that much, and I kind of want to, but I'm not sure that it's necessarily justified for this. But we'll see. I'll see what that cost is and figure all of that out. But yeah, so what we'll do is we'll get the boards. They'll just all be individual. They won't be panelized. The stencil will just be for a single one. Put the board down, put the stencil on top, squeegee the paste, lift off the stencil, place all the components, and then put it through the oven and get freshly baked circuit boards. Yeah, I feel like we could probably do one in like an hour, like for that whole process. The parts placement is what takes the longest because, I don't have a pick and place machine. So it's like hand done. Usually I usually do stuff with a microscope. So
I usually just shove my face right into it.
Robin still has young eyes. doesn't need the reading glasses yet, which these are my reading
feel like
glasses.
I have better control when it's like
when it's just in your face.
Yeah.
Yeah.
Hurts my neck though.
Yes. So yeah, Bob says that Osh Park always reminded him of Oshkosh because he's an aviation enthusiast. Yeah, I've heard a lot about Oshkosh. I worked with a lot of airplane nerds in my youth, so I've heard about it. Never been, but it sounded like a cool time. Yeah, a couple of those guys would like fly in and stuff. But yeah. All right. Well, it's 7:16, so we gotta wrap this up. I gotta finish my beer and like head on out. So, but yeah, thank you all for joining and coming and watching. And yeah, I don't know what's gonna be next week yet. I might take a break next week, maybe. I don't know. But if not, it'll be something cool. Oh, I like that. Yeah, I like that idea, Bob. Do the cooking show, swapperoo, right? Have the pre-placed board in the oven, like have it already done, right? While you're like, oh, and now we're making this, and boom, ta-da! Nice. Sweet. Awesome. Well, yeah, we'll tweet if there is next week or not. And yeah, hopefully see you then with more fun streams. Awesome. Thank you all for joining. Bye.